Hello dear students, today we are going to see application of matrices to find solution of system of equations. Okay, there may be three equations or two equations. We are going to solve these system of equations by using matrices. For the solution of three or two equations, we are already familiar with one method which is known as Cranmer's rule. But in this case, we are going to make the use of matrices. Let us start with its first method, which is known as method of inversion. As the name suggests, we need to find inverse of a matrix and we are going to make use of that inverse to find the solution. Initially, consider three equations like a1x plus b1y plus c1z is equal to d1, where a1, b1, c1 are coefficients of variable x, y and z. d1 is the constant term in that equation. Similarly, there are two more equations with coefficients a2, b2, c2 and a3, b3, c3 and constant term d2 and d3. Now we can convert this whole system of equation in the matrix form as shown below, where we call that matrix equation as Ax is equal to B, where A forms the matrix of all coefficients of x, y and z. Look at here, a1, b1, c1 are the coefficients of x, y, z from the first equation, therefore it is the first row. Then for the second row, a2, b2 and c2, and the third row a3, b3 and c3. For three equations there will be 3 by 3 matrix which is called as A. Then matrix X is the column matrix of all variables such that x, y and z. There are three variables, so there is a column matrix x, y, z. Now what about d1, d2, d3? They are constant term, we are not going to forget them. We are going to make again a column matrix of these three terms and we call it as a B. This is a representation of these equations in matrix form. Recall, matrix multiplication is row into column wise. So if you multiply first row with this column a1x, b1y and c1z, you will get this whole equation which is equal to d1c. Similarly for second and third equation, so we can convert this matrix form into equation form or equation form into matrix form. They both are equivalent. Now the method of inversion says if these three equations has some sort of solution, means there are some values of x, y and z which are satisfying all these three equations, then this matrix A must be non-singular, means its determinant is non-zero. And if determinant of this matrix A is non-zero, then obviously its inverse exists. So we are going to find out inverse of this matrix A. Okay, so to the next step, by considering this matrix as A, find its A inverse. Also, I am going to call this equation as equation number 1. Now I am going to pre-multiply by A inverse to this equation 1. So what happens? See, A inverse into Ax is equal to A inverse into B. But as per the associative law, you can write A inverse into A together. Then X is equal to A inverse into B. But you can say A inverse into A is identity matrix into X is equal to A inverse into B. And therefore I into X is actually X, which is nothing but A inverse into B. So finally we get the equation like X is equal to A inverse into B. Here X is nothing but the column matrix X, Y, Z. So this is how we can find out values of X, Y and Z by multiplying A inverse with this column matrix B. We are going to follow these steps to find out values of X, Y and Z by using inversion method. Now here is the most important thing, is to find A inverse. Now to find A inverse, you can use any of the method that we have already discussed, like row transformations or column transformation, or you can use the adjoint method. So no doubt most of us are very comfortable with adjoint method to find A inverse. This is the rough structure to apply method of inversion for 2 by 2 matrix. The method remains the same, just the matrix or the equations will reduce to 2 equations and 2 variable, means 2 by 2 form for the matrix A, and there are only 2 rows for all the 3 matrices. Let us solve some examples by using method of inversion. Let us start with 2 equations and 2 variables. So this is the question: x plus 2y is equal to 2 and 2x plus 3y is equal to 3. Initially, we are going to represent these 2 equations in matrix form. X is equal to b. See, variables of x and y in first equation are 1 and 2. So first row is 1, 2. In the second equation, variables are 2 and 3. So second row is 2, 3. 2 variables xy, so column xy is the matrix X, and 2 constant terms are 2, 3. Therefore matrix B is column matrix 2, 3. As we considering this matrix as matrix A, first step is to find A inverse. Now here A is equal to 1, 2, 2, 3. Therefore determinant A is determinant 1, 2, 2, 3. So which is 3 minus 4, which is equal to minus 1. Now determinant A is non-zero, and therefore you can say A inverse exists. Now you are all familiar with all the methods to find A inverse. Okay, row transformation, column transformation, or adjoint method. I am going to follow the adjoint method. For that, I am going to find out minors, cofactors, and then matrix of cofactors and adjoint. And with the help of adjoint, I am going to find out A inverse. As you all are familiar with these steps to find A inverse, so I am not going to repeat or explain all these things again. This is the inverse of matrix A. I am going to pre-multiply by A inverse 2 equation 1. See, A inverse into Ax is equal to A inverse B, where A inverse into A is I. So I can write I into X is equal to A inverse B, and I into X means X. Therefore, it is equal to A inverse into B. So let us substitute all those values. Therefore, X is equal to, I can say A inverse is minus 3, 2, 2 minus 1. So these are final steps. B, see, the matrix B is matrix of constant term, that is 2, 3. We are going to multiply these 2 matrices. The multiplication is always done in the form of row into column. Let us multiply minus 3 into 2, that is minus 6, plus 2 into 3 is plus 6. Then 2 into 2, 4, and minus 1 into 3 is minus 3. And therefore, you can say minus 6 plus 6, 0, and 4 minus 3 is 1. Here you can say X in means what? Look at here, X is the matrix of variables. So it is xy, and therefore finally, and therefore by using equality of 2 matrices, you can write X is equal to 0 and Y is equal to 1. You can verify these values by substituting these X equal to 0, Y equal to 1 in these equations. These are our final values. Let us solve this second example with 3 equations and 3 variables x, y, and z. As usual, I am going to write given equation in the matrix form. X is equal to b. Let us call that equation 1. 5 minus 1, 4. You can see the first row. Then 2, 3, 5, and 5 minus 2, 6. Variables x, y, z, and 5, 2 minus 1 are the constant terms. Here we call this matrix A, which is nothing but the matrix of all coefficients. Our first step is to find A inverse. So let us find out A inverse. Okay, so here we are ready with our A inverse. It is 1 upon 51 into this whole matrix. Let's use this A inverse to pre-multiply this equation number 1. Okay, so therefore we are going to write pre-multiplying by A inverse to equation 1. What do we get? A inverse into AX is equal to A inverse into B. Remember, pre-multiplying means we are going to take A inverse as a prefactor, means previous the given values or previous the given letters. Okay, so A inverse is the previous to A into X and A inverse is previous to the B. Now A inverse and A, they will form I, and I into X is equal to A inverse B, and therefore you can say I into X is X, which is equal to A inverse into B. So this is the required formula where we can find out value of X. X means this column matrix of variables. With the help of multiplication of A inverse means this matrix into B. B is column matrix of constant term. Okay, so let's do it. Therefore you can say X is equal to 1 upon 51 into 28 minus 2 minus 17, 13, 10 minus 17 minus 19, 5, 17 into B, 5, 2 minus 1, 5, 2 minus 1. So this is equal to, now always remember matrix multiplication is row into column wise. Multiply by each row to this single column. Okay, so this is equal to 1 upon 51 as it is, and you can write 28 into 5 is 140 minus 4 minus plus 17. Then 13 into 5 is 65, and 10 into 2 is 20, and it is plus 17 again. Minus 19 into 5 is minus 95. 5 into 2 is 10, and 17 into minus 1 is minus 17. This is equal to, I am going to write again, 1 upon 51 into, see, if you calculate all these value, you will get this value as 153, then 102 and minus 102. Now look at here, if you multiply by 151 to each of this number, it means actually you should divide by 51. So 153 divided by 51 is 3. Then 102 divided by 51 is 2, and minus 10 divided by 51 is minus 2. Okay, so therefore you can say that value x you can write it as x comma y comma z, which is equal to, that x means the column matrix x y z, which is equal to these values. So by equality of matrices you can write x is equal to 3, then y equal to 2, and z equal to minus 2. Now to verify these answers, you can substitute all these values of x, y, z as 3, 2 and minus 2 respectively in left side of these three given equations, and check whether the right side comes to be 5, 2 and minus 1 respectively. That's all for this session, but before I take your leave, I am going to repeat the major points. Initially convert these equations into matrix form, then find out A inverse by using either of the method, row transformation, column transformation or adjoint method. Once you get A inverse, pre-multiply by A inverse and write down the formula x is equal to A inverse B, and actual multiplication of A inverse into this B will give you three values of three variables. Here we use A inverse to find values of x, y and z, and that is why this method is called as method of inversion. That's all for today. Thank you, and finally like the video, share to others and subscribe the channel. Thank you. Bye bye.